we've got more people coming in. Come on in and sit down, guys. Yeah. Cool. So my name is Hunter Loftus, and I'm responsible for the Node.js platform at Heroku. And so if you use that platform and you like it, I've got my Twitter handle up there if you want to talk about building games on Heroku. That's awesome. If you have problems with it, your build isn't working or something's failing, you get an npm error, my email address is also up there. So send all your angry emails today. So when I'm not maintaining the build pack and doing support tickets for Heroku, I run a little website called PlayfulJS. It's kind of a place where I get to explore playful JavaScript. I really enjoy playful coding, building graphical systems, terrain generation, particle effects, stuff like that. Things that you frequently see in video games, but you also see in other places. And you might have seen this on Hacker News sometime towards the end of last year. One of the things that I built was a recreation of the Doom rendering engine in JavaScript. It was pretty short, it was pretty fast, and maybe most importantly, it worked on just about every device. You could run it on a really old iPad and old Android. And this is the sort of thing that I like to play with. So nothing in here is going to be like modern game development stuff. This is mostly a throwback to things that people figured out in the 80s, but that we're just now kind of bringing into JavaScript because we're a little bit behind. So after I built that, I got contacted by this company called Warp Records, and they said, would you be interested in a project for one of our artists? They wanted to build an HTML5-based video game that's very much like that first-person shooter engine for an upcoming album release. And I was like, well, this is an intriguing idea. This is really cool. I used to build Flash games, but nobody has ever until now offered to pay me to build a JavaScript-based game. So I decided to talk with these guys. They were based in the UK. And one of the issues with this proposal was that they had just discovered this first-person shooter, and they were about to do a major international launch 3 weeks later of this album, and they were like, so can you have it done in 3 weeks? I was like, I mean, maybe, and I'm kind of rationalizing to myself, I've already built that FPS engine, so it's like 80% finished, right? The second issue was budget. Since they hadn't really found me until the very tail end of their marketing effort, they only had a little bit left to throw into like an online budget. So I was like, okay, so it's also going to be really cheap. Well, you know what? I love doing this stuff. I do it for free on PlayfulJS, so why not get paid even a little bit to do it, right? And the third issue was the technical constraints. It had to work everywhere, and that's what initially attracted them to the project. Right? They were actually using an old iPad, and they saw that this thing would run on it. And that was really important to them because it's a marketing effort. They wanted people to be able to just click on a link and go play this game, and their idea for the game was really cool. They wanted you to explore a world, and in that world be able to discover different songs that were on this album. And then if you beat the game, you get a link to SoundCloud, and you can actually play these songs on your own like SoundCloud and kind of get a preview of the album. And I thought that was a cool idea. I thought it'd be fun to work on. So unfortunately, though, there were those 3 issues. So I had to say, sure, let's do it, right? Like, let's just go. Let's I rationalized and I talked myself into it, and I decided to just jump ahead. And I felt kind of good about this because I was like, you know what? This album for an electronic artist named Rustie, who I'd never heard of. I was like, it's an indie label. I was like, so it's me, an experienced web developer. I'm helping out the little guy. I'm getting indie music out into the hands of the people. Like, this will be a cool project. And I imagined like 3 weeks. What does that mean? He's going to tweet to some friends, maybe put up a link on SoundCloud. Like, if I need to, I'm sure he'll push back this, international release if the game requires it. And so I accepted the project. And then my girlfriend, who's way more into music than I am, found out that I accepted this project, and she sent me a bunch of links. And it turns out that especially in the UK and especially in Europe, this guy is a major deal in like indie electronica. And like international release was a real thing. And that's when I discovered that it wasn't me helping out like this no-name artist. Like, I was the no-name artist And he was giving me an opportunity to, demonstrate some ability. So anyway, that added a little pressure. So then for the next 3 weeks, I basically didn't sleep. And I built a custom rendering engine for this game because, of course, the first thing that I wrote wouldn't work for the vision. And so it renders about 4 million rays a second. It's all done in Canvas. You can probably tell from the screenshot, I spent a lot of time watching Minecraft development videos. Because Minecraft was written in Java, and it was originally a software renderer, and so it had a lot of the same constraints that you have when you're working in Canvas. So this actually turned out to look and feel a lot like Minecraft. But anyway, I wanted to show it to you, just so that you can see what I ended up with. I won't play through the whole game, but I just wanted to show a little bit. So this is green language. Let me see if this will work okay. Yeah. And you might be able to hear, for some reason my sound is disabled, but you can still hear it, so that's cool. So like you start out and you can hear some music, and it's like very exploratory. And so you wander around a pretty large procedurally generated world, and you like find things like, you see it there, like a little golden sort of stone, and when you touch these things, that's when you collect new songs, right? And over the course of the game, you collect more songs. Some of them you find that way, and others you find by performing certain actions, right? Like this is a spring, a very low resolution spring. And like it brings you up into this whole other world where there's like sky temples and things. And it starts playing different music that's telling you that you're gonna go down, right, when you start springing around. And anyway, so I actually really liked the music. That's one of the reasons I took the project. Like, I thought it was cool. So anyway, I'm really bad at my own game. But there's like all these little hidden things and like little challenges. I'm not gonna solve the maze because I can't. But there's a maze, and this is my favorite feature, and this is where I'm gonna stop this particular demo. But you see how the land changes as you go over the maze? Well, once you retrace your steps enough on this like dark area, it realizes that you're lost, and then it plays his song called Lost. So I was very happy with that. So anyway, that's what I ended up with, right? And I was really happy with it. Until 1 month later, when Apple released WebGL on iPhones, and I could have just written it all in WebGL and not invented my own rendering engine for this project if it was just 1 month later. But, well, I learned a lot of trigonometry. So, and I also got featured in Kotaku, which is not something I ever expected to do. And so now, if you were to describe me as a professional video game developer, you would be technically correct. Which is the best kind of correct. So, but you might be asking yourself, I'm not a video game developer, so why do I care about this? What does it matter to me? And actually, it should matter a lot because application interfaces are starting to look a lot like games. You know, if you've been following along with the Oculus Rift, which Facebook now owns, or the Leap Motion device, or with Microsoft's new thing, which I hope really comes to fruition, because this thing looks awesome. This like HoloLens, like move around a 3D world, like design a motorcycle in 3D. That's just, it's amazing, right? And other developers, non-JavaScript developers, are going to be working on this stuff unless we figure out how to, right? Because right now, most JavaScript developers would not be able to, even if the APIs were exposed to JavaScript, they just wouldn't be able to work with this kind of data, this kind of like 3D immersive simulation. That's just not where we're strong right now. And so we need to get better at that. And it's not just for future applications. It's also for applications being built right now. If you've taken a look at Google's Material UI, some of the foundational principles are that this material should behave in sort of a physical way. Animation should mean something. They should be simulations rather than just pre-scripted animations, right? And so like, if you're trying to build a modern Android app right now, you should be using Material UI, and that's actually pretty hard with JavaScript, right? Because we are limited, well, we appear to be limited to what we can do with CSS and with pre-done animations. We don't do a lot of simulating in JavaScript, so that's why it should be important to both game developers, aspiring game developers, and people who couldn't care less about ever building a video game. And there's one more reason. And that's something that you'll discover if you ever just try to spend a weekend building a game. Pick an old game, Pong, Asteroids, Pac-Man, whatever, and try to build it in a weekend, and you'll discover that it's the hardest code you have ever written in your entire life. Building a simple game is harder than building most complicated web applications. And so there's a lot that we can learn from games. We can really level up with video games. Okay, so that's a note, and I do have 15 minutes left, so I'm good to go, right? So today, even though there's a lot that we can learn from game developers as JS devs, we're only going to look at sort of 3 things. I wanted to focus on 3 things. And we're going to focus specifically on user interfaces. So 3 takeaways that we can steal from the game dev community about how we can build better UIs in JavaScript. So the first is that state is the root of all evil, right? And traditionally, JavaScript developers have been very bad about just throwing state everywhere. It's so easy for us. We can attach state to anything. Everything is an object, and everything is something that we can just attach properties to. Those properties don't need to be typed. I mean, it's just so damn easy to add state to our applications that it's a very prevalent practice. But game developers, they don't have that luxury, and you can kind of see with this example. All right, so this is how we test JavaScript frameworks, right? Like this is the standard JavaScript framework test. Compare this to a modern video game, right? How much state is happening here? You have like a rocket flying through the air. You have guys shooting at each other. Multiple things are on fire. Like, and more importantly, this game is updating every 16 milliseconds. Right? So we have debates about which MVC framework will update your list of 1,000 items in under a second, right? Like, this is updating every 16 milliseconds. So there's obviously a lot that we can learn from game developers. And one of the first things is that they've developed a couple techniques to tackle environments that have lots and lots of state that interacts with each other really, really frequently. So I wanted to show you a little demo of what that can look like. This is a little piece of a game that I was messing with a friend, right? I would write a piece, send it to him. He would write a piece, send it back. It's actually kind of a fun thing to do, and like it's a little mobile game. And right now we've got like this dude, and he like runs around, and there are trees, right? There's not a whole lot other than this. It's not actually a game yet. It's just a guy that runs through a forest. But when we initially built this, we started talking like normal JavaScript developers. We were like, what's all this stuff that we need to keep track of? Well, what direction is he facing, right? Is he facing right? Is he facing upper right, up? And then what frame is he in? There's 72 different frames of animation here for each different direction and different. So we've got to remember like which direction he's facing, which frame of running that he's on, and then we wanted to make it so that like when he went slowly, he like walked slower, and then when he went quickly, the animation. So now you got to figure out like how fast is he moving, and how does that impact the current frame that he's on, and then when he changes direction quickly, we wanted dust to kick up. So there's all this different state that's happening here with this player, and so our initial like state object for this was just enormous. And then we were like, wait, no, hold on. We're gonna boil this down. And we ended up being able to write it in just this. This is all the state, actually, in that entire little running simulation. And you notice there's nothing here about frames or directions or anything like that. And the reason is we use something called a pure function. Some of you may have heard this. If you've ever taken like a functional programming Lisp class in college and hated it like I did, you've heard of a pure function, but they're actually super, super powerful. And they're really simple too. The idea behind a pure function is it has no side effects. It changes nothing. It takes some predefined type of input, and then it produces some type of output. In this case, you can send it the x and y coordinates of the guy, which are stored as an array of the last 3 x and y coordinates. And then you can send it the time interval, which is also an array of the last time intervals. And then it will figure out how fast he's moving. Once you know how fast he's moving, you now have like a vector for his velocity. You can put that into direction, and you can compute where he is facing. And then you can you can basically figure out how far he has moved by adding all of those velocities up, and you can figure out which animation pose he needs to be in. And a nice side effect of that is it'll automatically make him run faster when he's moving faster. It'll animate faster when he's covered greater distance, and more slowly when he's covered less distance. And so it's a really elegant solution. And the nice thing about this block of code here is that there is no chance it is introducing bugs like outside of itself, because it has no side effects. It changes nothing. There are no variables set at all inside any of these particular functions. Right? So that's a pure function. So one of the things we can learn from game developers is wherever possible, minimize state, explicitly point out where state lives, and then use pure functions to try to delete as much state as you can, right? Figure it out on your own. And also, I'm going to, whatever. All right, I'm going to move to this screen so that my computer doesn't die while it's animating all that, because I'm not charged very high. All right, so the second thing that we can learn from game developers is to enforce deterministic rendering. And all that means is that if you have a blob of state, you should be able to send that to your renderer with no other data, and your renderer should be able to make everything, right? For instance, your render function should look like that, which is a little bit shorter than most of my traditional render functions have looked. And it's important for a lot of reasons, and one of them is that it makes sure that you are encapsulating all of your state data in that state object. If you have to send more stuff to your render function, then there's actually state that's living in places that you aren't sure about, right? That you're not tracking. And that makes it hard to do things like undo and redo. It makes it very hard to do to save things, right? Like if you're trying to make if you're trying to make Keynote, and I want to save a whole bunch of undos. Well, if I can just save them as blobs of state, and then just go back through those blobs of state, and then move forward through those blobs of state, I now have free undo and redo, right? Stuff like that. Imagine how hard that would be if every time you change something, it's actually directly manipulating properties on some sort of an object, right? On some sort of an instance of an object. It makes things very hard. And for multiplayer or multi-user applications, you can't actually send JavaScript instances over the wire, right? You can't say, var player equals new player, and then send new player over a WebSocket. That's not something you can do. You have to have a JSON object, right? So if you're not representing all of your state as something that could be put into JSON, you're setting yourself up for much more difficult integrations later on. I wanted to demonstrate this. I'm not sure if this is going to work. Let me put this caveat in here. I wrote this in a couple of hours over a weekend, and it may or may not work. I don't know. I've never tested it with more than 2 people, right? So we'll just try it with you. Anybody who wants to, open up this URL, right? And I wanted to highlight that this is all the code that it took for me to turn a single-player game into a multiplayer. Well, we'll see if it works. Let's see if it works before I start bragging about it. All right, so I'm going to refresh this. And, is everybody on Wi-Fi? I guess that's the other question. Yeah? No? Not everybody? All right, well, whoever's on Wi-Fi, join here. Oh, we're all blue. There's one red guy. That poor red guy. All right, so I didn't say the game logic was perfect, right? Yeah, we're all blue. All right, well, that's fine. So let's just say I intended to make this game one where you actually hunt the red person, the single poor red person who's running from everybody else, right? Anyway, so what's kind of neat about this is I just hacked together a little thing where you spin and you shoot and whatever, and it's got state. And then I wrote this tiny, tiny little 3-function, 50-line thing, and because the rendering function only takes this one state object to work, it actually, sort of worked on the first try, right? I mean, sort of worked. But we are all living in the same environment. We can't kill each other because we're on the same team, but that poor red guy cannot, he's just screwed. So anyway, that's just one of the benefits of keeping state independent. Let me move back here. So what's kind of neat about this is this is the network code for that game, right? This is 100% of the network code for that game, because it's using as many pure functions as possible and just storing state as these very simple little objects. So another more polished example of that type of thinking is React. They do some really interesting stuff, and one of the coolest things React does is render to string. You give it a state object, and you give it an element, a component, a React component that you want to render with this state object, and it will give you like the whole HTML markup, everything that you need to render that as a string, which is really cool because it lets you use React to do pre-rendering on the server with almost no extra work. So you can like render something on the server, send that over, and then send the exact same code over to the client, and it'll like automatically convert into a single page app that was pre-rendered on the server for like a really fast first load experience, which is amazing, right? So React under the covers is actually written very much like a game engine, actually, and it's kind of cool to look at. It's been compared to Doom as well in its rendering pipeline. So the third thing I wanted to talk about that video game developers do that we should start doing is separating rendering and simulation, because this is definitely not normal in JavaScript. So let's talk about why you would want to separate rendering and simulation. And let's also make sure that we understand that simulation is what leads to animation, right? It's what leads to good animation. I'm not even really going to talk about animation here. Traditional, move from this spot to this spot animation, we can do that fine with CSS. But modern interfaces require simulation. When you want somebody to have scrolling on your device and you want it to have some momentum and you want it to have some bounce, when you want your draggable icons to have a little bit of weight and mass, friction behind them, you have to run a simulation. There's no way to do that with a stock animation. So we don't really write a lot of simulations in JavaScript. So let's talk about how you can get 60 frames a second simulations in JavaScript, because it's not request animation frame. One thing to point out is that at the cinema, you get 24 frames a second. Do not think that means that 24 frames a second is okay, right? They chose that back when film was very expensive as a material, and this was the lowest threshold that you can watch without just getting sick, right? So 24 frames a second is not a goal to shoot for. 18 frames a second is about as low as you can even make out motion rather than independent frames. And then fighter pilots can see up to 220 frames a second, right? They can see a jet that's in their vision for only 5 milliseconds. So we have a very high threshold for animation. So we should be aiming very high. So, if you're delivering less than 60 frames a second in any of your online experiences, then you should reevaluate it because we can do better. This is a hand-drawn browser timeline. Bear with me. This is how you might initially think you would make the smoothest animation possible, but most people here probably know that this is terrible. This will cause your computer to sound like it's about to take off. It'll eat up everybody's battery, it'll get really hot, and none of the other tabs will be able to continue functioning, right? So this is not a good way to make smooth animation. So the next thing people tried, and this is basically how jQuery works, is you delay by about 17 milliseconds, which is approximately 60 frames a second. The problem is set interval does not guarantee, one, that you're going to be updating anything when the display is actually being redrawn, and two, it doesn't guarantee that you're actually going to be redrawing anything after 17 milliseconds. It's a minimum of 17 milliseconds. So you're not going to be doing anything in 15 milliseconds, but it could take 100 milliseconds. You don't know. So there's no guarantees with set animation frame. So now everybody thinks that request animation frame is like the holy grail of animation, and we finally solved this in JavaScript, but we haven't. We definitely haven't, because request animation frame guarantees that you are drawing at the right time with regard to rendering, but it makes no guarantees that you will be rendering at 60 frames a second. If that user's antivirus starts, you will drop frames. If they create a new tab, you will drop frames. If you do anything that's CPU intensive, you will also drop frames. So you can definitely drop frames while you are using request animation frame. And now I'm going to show you why that's bad. Because people are like, oh, if you drop frames, who cares, right? This is why that's bad. So this is a little test of a physics engine that I wrote called Newton. It's a terrible physics engine, never use it. But I wanted to point something out with it. So I'm going to just refresh it a few times, right? And you'll notice that every time I refresh it, it does something similar to the time before, but not the same. It never behaves the exact same way twice, right? Sometimes two things bounce off and then the third bounces off. Sometimes, well, that was pretty similar. Sometimes one stays on the platform, right? Like different things happen every time. If you run your software multiple times and it does something different every time, you're doing something wrong. right? So even though it sort of looks like it's kind of working, this is definitely not what you want, because imagine how impossible this would be to test. You can write automated tests for this. So instead, what you do is you decouple your rendering from your simulation, and you always, you do draw on request animation frame. You render on request animation frame. But you notice here I've dropped a frame. That means that I do 2 simulation passes before the next frame. So you basically track how many frames you've dropped. And whenever you drop a frame, you run your animation loop or your simulation loop twice. And I will show you what that leads to. That leads, all right, so this is a 10 frame a second simulation, right? All right, so it's going to go really slow. Imagine like a really slow mobile device running this, right? But you notice that every time it ends up in the exact same state. It's really, really slow, but it does the same thing every time. Now, let's say we're running it on a new fast computer. It does the exact same thing, just at a higher frame rate. This will do the exact same thing over and over, and it really did, because I'm so nervous every time I do this. It's never not worked. But there's going to be some time when it doesn't do the same thing, and but so far it's worked perfectly. So that's why they need to be decoupled. And you can decouple them using several techniques, but my favorite is something called a time accumulator. Some people call it a time buffer. I'm not going to go into this too much. This is something that I'd be happy to talk about afterwards, but it's sort of a topic unto itself. It's actually a pretty simple concept, but it just sounds complicated when you give it in a presentation like this. So feel free to look up time accumulator. All it really does is you just store an integer, and every time time passes, you add that new time to the integer, and whenever it's greater than a certain amount, you delete that certain, that just sounds complicated, doesn't it? But it's really not complicated. Time accumulator, I'll talk to you about it after the presentation. And now, since I'm getting towards the end of the talk, let's see. Yeah, I've got 1 minute left. I'm going to show you my favorite bug ever. This is a bug that I created, and it was so amazing when I first saw it that I actually created like a git tag so that I could always find this bug again. It's the coolest bug you'll ever see. It's way better than the physics engine that it's in. So, all right. So here we go. And again, every time this works the same. I hope it works as well today. Like, hasn't failed me yet. All right, here we go. So, I should provide background. I was sitting in a cafe trying to get my stupid physics engine to render boxes, and that's it. Just render boxes. It's harder than it sounds. All right, so check this out. So I thought I finally succeeded, and then and this is the sort of bug that if you told me to do it, I couldn't. And then watch what happens next. This will blow your mind every single time. All right, and then it bounces, and then it's a box. And for the rest of this program's life, it will stay a box. I have watched it for hours. So I wanted to leave you with this bug because, one, all good software developers leave somebody with a bug, but two, because it illustrates, like, I couldn't bring this bug to you if I couldn't reproduce this really quirky behavior every time over and over. So this bug is brought to you today by the principles that we just discussed. So I think I'm out of time. Here are a couple links that might be useful. I strongly encourage you, if you're going to build any of these apps or these games, to try it on Heroku, because we do all sorts of really awesome stuff, and it's free, so you might as well. If you want to chat with me after, I will be hanging around. I'll be watching the talks, and if you want to get in touch on Twitter, my handle is right there. And thank you so much for coming, everybody.